Okay, so tell me about the second project you've chosen.
So this one is about folding the angle bisector. It's actually pretty simple with patty paper. So
Okay.
first you have to find your angle. Actually, just create your angle at first. So you draw two lines like this. So you have your angle here. And then what you do is you just fold over so that they line up. So if you
Push the paper forward just a little bit. Good.
get it so that they line up, fold all the way out like that. And then we unfold. And then we have a line that's going through this point here, and then it goes.
Yeah, maybe it might be that one's a little harder to see. Can you just sort of highlight it in, with the ruler, just so we can see it?
So it's this line
Okay, perfect.
right here was created by the fold.
Okay.
So we know that this line is, since we folded it over, we know it goes through the point we folded it through, which was the vertice where the angles meet, and then we know it's equidistant from both sides because we folded it over like that, and then we have the same length here as we had here.
Okay.
So that means that these two must be the same angle.
Okay, so pick a point on that line a little bit further down from where you're marking the angles. Okay, so what does it mean for that point to be the same distance from those two lines? What does that mean?
So it means that it's the same distance away if you drop down a perpendicular here
Okay.
and a perpendicular here. It's the same. Yep, it's the same distance away.
Alright, mark those perpendiculars. It's fine if they're not exactly perpendicular. We'll just say those are perpendicular. Okay, so how do I know that those two distances are the same? So what are the ideas from geometry?
Well,
Not from folding, but from geometry.
so we have to say that we have to prove that they're congruent triangles. So we have this side here. We already know because it's the same side. So if we know from the angle, since this is the angle bisector, if you drop down the perpendicular, this here is the same distance as this.
Okay, how do we know that?
Well, we know we have the angle bisector.
Yeah.
So that means it's the so it's the same distance from the sides of the triangle.
Okay, yeah, no, but yeah, that's what I'm asking. How do we know? Is there any way at all you can show me that those two distances are the same?
Maybe if we drew like a side here, but then we wouldn't know if these two would be the same.
Yeah.
So what else do we have an angle, so we have a side and an angle. We need another side, at least.
Yeah, it'd be nice if we had another side, but there's actually another option.
Or we could get another angle.
Okay.
So if we know the perpendicular, or since we know that these are both perpendicular, we know this angle as well.
Yeah? Why do we know those two angles are the same?
Well, we have the same angle in both triangles, and then we have the same perpendicular in both triangles. So it means we're going to have the same distance left in both triangles for the last angle.
Okay.
So we have angle, side, angle congruency.
Very nice.
And then we know these two distances.
Yeah, and why don't you fold it over and see, like, how close did you get to? Are those nearly on top of each other?
Nearly, yeah.
Cool.
Just about.
Good job. All right, hey, high five. Good work this morning, hun.